This is section 1.5a. We'll be solving absolute value equations here. You should remember what absolute value is, but let me just give you a quick refresher in case you don't. If you're talking about the absolute value of -3, the absolute value of -3 is 3. It's the distance on your number line. If you're talking about the absolute value of 3, it's also 3. Now what we're going to look at these is kind of setting them up on an easy one, and then we'll get a little bit more challenging. So once you have your absolute value sign by itself, all I do have is this absolute value on one side of my equation. You want to set it up and split it apart into two equations without your absolute value sign. So I'm going to take my stuff inside my absolute value. That's going to be in both equations. The first one is going to be equal to this value here, which is going to be 12. The second one's going to be equal to -12. Now here's the reason why. If you're talking about this value right here with whatever y happens to be, when I simplify it down, it could equal 12, or it could equal -12, and then I would take the absolute value of it and get 12. So there's these two possibilities here. Now that means you're going to have two answers in a lot of these. I'm going to go through and I'm going to solve for the y in each situation. So y equals 8, and over here, same kind of thing. Y equals -4. Now, typically, these are fine. It might be a good idea to check them. You can always plug these numbers back in, make sure that they work. But there is going to be a situation that we have next where you have to check them. So these are okay. This next situation you do have to check. Oh, and I gave you room to check it here. Just for the sake of time, I'm not going to check these. We did that. We're going to check them in class. But you will want to plug them in, kind of see what your value happens to be. Okay, so here's our second problem. You'll see one big difference here is that you've got an x inside your absolute value sign, and you have one outside your absolute value sign. In this situation, you have to check them. If there's an x inside your absolute value and one outside, you have to check them. If you don't, you're going to get some extra answers that aren't valid. So you have to check them. So whereas we skip checking the last one, we're not going to skip checking this one. Now I'm going to do the same thing. I'm going to take my x minus 1, and it's going to be in both my equations. The first one is going to be this value here. The second one is going to be a negative version of that, like in the last problem how we had the -12. Now quickly I'm going to go through and I'm going to solve these. So I'm going to move the x to the other side of the equal sign so that I have 4x. I'm going to move the 10 to the other side so that I have -11, and then divide by my 4. So in -11 over 4. Okay, same kind of thing, except I need to distribute out that negative first. Okay, so I'm going to bring my 5x over. I like to keep my values positive, so that's the choice I'm going to make. And I'm going to add to the other side, so -9. Now, when I reduce this, I'll have -3 over 2. That's a 3 there. Okay, now on these, I do want to make sure that I go through and I check them, because it's possible that one of these two doesn't work. Remember, situation when you've got to check them is if there's an x inside the absolute value and there's an x outside the absolute value. So I'm going to check them just using a different color here so you can tell the difference. So I have -11 over 4 minus 1, and 5 -11 over 4 plus 10. Okay, so I'm going to rewrite the 1 having a common denominator of 4. So I'll have negative 11 minus 4 is negative 15 over 4. Take the absolute value of that and I have positive 15 over 4. Okay, over here I have negative 55 over 4. And I'm going to rewrite this as being over 4. So I'll total have 40 over 4. So when I simplify here, I'll have negative 15 over 4. Now I want y'all to notice here, these are not equal. This one's negative, this one's positive. They're not equal, which means this answer is not valid. You've got to be careful on these, because if you don't check them, you don't know that you've got this extra answer. It's called an extraneous solution. You don't know it's there, but it is. Now, because I'm going to run out of time if I'm not careful, I'm going to tell you this one does check out. So when I checked it in my notes, it does check out. It's a valid answer. Both sides of the equal sign equal the same thing, so it's a good answer. You can keep it. But you are going to have some of those extraneous solutions, so be careful for them. Okay, so here's the next one. Now, looking at this one, you don't have to worry about checking it. Think about it for a second. The reason you do not have to check it is because there's only an x. There's only an x inside your absolute value. And remember, you don't have to check it if there's only one inside the absolute value. It's if there's one inside but not one outside. Now this one is different from the ones that we've had before, because that negative 4 is not inside the absolute value. Before, we had that absolute value by itself on one side of the equal sign. What we want to do is fix that issue. Get that absolute value by itself on one side of your equal sign. Usually it'll be on the left-hand side. Then you can do the same thing we've done before. Set up your two equations. 2x minus 3 will be in each of them. And solve. So I'm going to solve quickly here. Solve this one, same kind of thing. So here are my two answers. Remember, you don't have to check them. You can if you don't feel confident or if you just want to, but you don't have to, because there's only an x inside the absolute value, not one out inside and one outside. Okay, let's do one more of these before we look at our weird situation. Now this time I've got two things that are not inside the absolute value that are on this side of the equal sign. So I need to get rid of both of those. So I'm going to start by adding my 5. So that'll leave me with 3, 4y minus 1. And then I'm going to go through and divide by my 3. Now see how I fixed that problem of having extra stuff in there? Make sure you fix that first. Then you can set up your two equations. And go through and solve. So I'm going to do this pretty quickly. Add the 1. So this reduces to 3 over 2. And going through and solving on this side. Oops. So I have 4w equals negative 4. W is negative 1. Okay, now this one we do not have to check because there's only a w inside the absolute value. Again, if you want to check it, that's fine, but you will only have those extra solutions when there's a variable inside and outside. So this one you can check if you want to, but you don't mathematically have to. Now, here's the last thing that I want us to think about. And we haven't had one exactly like this before. I gave you a little one here. But I want you to think about if this is possible. Is it possible to have a negative value right there if there's an absolute value on the other side? I think the answer is no. Like, let's say that x is -4. Then you take the absolute value of -4 and get 4, right? So the thing is, you can't have a negative value that's equal to an absolute value because it's just not possible. So if it's not possible, the mathematical way to write that is no solution. You can write it out this way, or you can use the no solution symbol. It's your choice. But it's not possible. That number cannot be negative. All right, so this is 1.5a.